So it's my great pleasure to introduce Brian Arthur. Now, some of you may not know this, but Brian was really the first economist to get his head around digital competition. And I go back to the 80s, and there was a number of papers and books, and Brian is unusual in as much as he's both a theoretical economist and an applied economist, but believe it or not, he can also talk to executives and venture capitalists. And as a consequence, he not only developed a rich understanding of what was going on in digital competition, but he was able to write it up, and most of the economics profession fed on him. So you think about a book like Varian and Shapiro, Information Rules, most of the fundamental thinking behind that was done by Brian a decade and a half earlier. So it may not be as well known and well cited in the IO literature as some others, but he's a bigger thinker than most of us, and certainly a bigger thinker than many that have put it in print. So that's one aspect of Brian. The other aspect of Brian, which some of you may be aware of, but most are not, is that he's also, while trained as a neoclassical theorist, a bit of a renegade, and he has been hanging out with naughty people like Nobel laureate Ken Arrow at the Santa Fe Institute, and really thinking that all of our economics is not quite right, and we need something called complexity economics, because the world is way more complex than our simple, silly models often presume that it is. And so I, needless to say, have great sympathy with complexity economics. I'm bewildered by the complexity of complexity economics, and not being anywhere near as smart as Brian, had to develop simple frameworks that bring some of that complexity into the real world in concepts like dynamic capabilities, which I describe to some people as a poor man's or poor person's complexity theory, or a poor person's systems theory, because there's very little that we have out there in the literature that really pulls the bigger picture together. And of course, the competition agency, as well as anyone in doing public policy, as well as executive management, of course, needs to understand that bigger picture. And Brian has provided that with some of his pioneering work in complexity economics. Today, I understand he's going to talk a little bit about that and also work with this group to bring the capabilities story into the picture, because I think the concept of capabilities was implicitly there all along in what Brian was doing, but in terms of drawing it out, I've had to hold him upside down by his ankles and shake it out of him, and I think we'll hear about it today. So without more, Brian, the floor is yours.
Thank you very much. As long as you can hear me, I'm going to stand up. I know it's late in the day and we've been sitting all day, so at least I get to stand. How can I get this to work? Hey, good, that's the start. Well, I know it's late in the day and I hope you can hear me properly. What I want to talk about is, well, I can show you on one slide here, if I can get this to work. I want to talk about any connection, or my imagined connection, between dynamic capabilities and complexity economics. I know a lot more about complexity economics than I do about dynamic capabilities. And I just chose one of the people in dynamic capabilities at random, not quite at random. This is chosen for good looks. So I thought I would put David on the board here. Anyway, the question I want to ask is, what is the connection between dynamic capabilities and complexity economics, if any. If we look at the economy as an evolving complex system, which is what I intend to do, would that lead us on a pathway to come up with dynamic capabilities ideas as an inevitable part of the economy? My answer to that is a very strong yes, that along the way, dynamic capabilities come up naturally. I don't think I'm going to show you too many new versions of dynamic capabilities, because as I read that literature, people here, and especially in Berkeley as well, had thought of just about everything that I will mention in passing in dynamic capabilities. But maybe here and there we can have a go at something new. So let me get going here then with the story. As I see it, the economy, I want to define an economy not so much, I looked it up in a dictionary, and the dictionary tells me an economy consists of markets, and those markets are for trading or exchanging, and prices evolve or appear, and everything is sort of nice and neat and rather unchanging. That's not the way I want to look at it here. I'm saying the economy is a vast set and a very heterogeneous set of activities and arrangements. The arrangements themselves could be technologies. I'm arranging that if I put this together with that and that together with this, that will result in such and such in an engineering way. Or the arrangements might simply be institutions, or they might be, or we might have actions as well. So I'm starting with a slightly different set of basic, just basic ingredients here. And the agents or players in our economy so far, largely banks, consumers, producers, shipping companies, international trade companies, government departments, they're not just experiencing or acting based on the outcome they see directly, they're reacting to it. The reaction might be do the same as you did 2 days ago, do the same as you did last month. So maybe there isn't much change, or maybe there's very smooth changes. But what the picture I want to give you is that this is vast, heterogeneous, and complicated. And understandably, economists might have had that in their hearts all along, but couldn't do much about looking at the economy this way until the 1980s or so, when we all got desktop computers. Those are relics now, but we have laptop machines or very large computers, not much in between. So I want to look at the economy in a somewhat different way, start from a different way. And before I do that, let me just say what economists have done. This was mentioned by David and others this morning. They did something I call the neoclassical finesse. Finesse is a great word. I'm sure it's French. Why do I know it is French? I do not know. Anyway, the neoclassical finesse, if you look up finesse in a dictionary, and I enjoyed doing this a day or two ago, it tells you it's a kind of a stratagem. What is a finesse? A stratagem, a sort of series of trickery, maybe in a negotiation or in a card game. So a finesse is something not quite clean and clear. It's kind of, well, we can't really solve this problem, but maybe if we change things around when no one's looking, we can solve something in the economy. And in particular, economists, as all of you know, this is the way I was taught in Berkeley, the neoclassical paradigm. We're going to assume all the players in the economy or in the part of the economy we're looking at are absolutely identical. So they're all clones. And they also know that everybody else is identical. And therefore, they know that everybody else also knows that everybody else is identical ad infinitum. All the problems these agents face are well defined. So if an agent is trying to solve a problem, it's well defined enough that we can reduce that to logic. And we're going to assume that the agents can do logic. So these agents we're going to play with are going to be totally rational. A lot of this, by the way, came out of MIT and other places before that, and England as well, in the 1800s and on up. I'm not quite criticizing this yet. I'm just saying this is the way neoclassical economics got set up. We're going to assume equilibrium as well. So we want to keep the animal still, or we want to keep the insect still. We're going to ask how butterflies fly. So we'll chloroform them and nail them to a board, and then we'll test the wings to see how flight might be possible. So we're going to assume that agent behavior is consistent with the outcome it produces, and that outcome isn't going to give any incentive for new behavior. Everything's at equilibrium. If I sound a little cynical about this, I'll tell a very quick story. When I first went to Berkeley, my training is largely as a mathematician. And my advisor was a very well-known mathematician called David Gale. People talked about man years and Gale minutes. And Gale looked at my resume on the way and he says, I see you're getting interested in economics. What have you read? I said, Samuelson. And he looked at me and he said, oh, wonderful, wonderful. He said, you read Samuelson. Of course, you mean Samuelson's Foundations. That was setting out this entire program in the 1940s. No, I said, I read the elementary textbook. Gale's face fell. I had read the undergraduate version, which is sort of the comic book version of Samuelson. And I learned a lot from that. It was beautiful economics. Later on, I read the Foundations, and I was less impressed. So all of this got set up, formalized in the 1940s. I think David this morning talked about physics envy. Samuelson being very heavily trained as a physicist, as an undergraduate, admired these maximum or minimum principles of energy and so on. And we inherited in economics a lot of that, and also from the University of Chicago, bless their hearts. This is what we got as a result. This enormously intricate and impressive machine of neoclassical economics. That's why I asked the curtains to be closed, because this should be shining, and it's highly ordered and highly rational and humming along. And in the extreme perfection version of this, it doesn't change. It's just humming along. And then you can maybe rev it up a bit by adding technology or something like that. Anyway, in in 1980, a long time ago, 1987, Kenneth Arrow, I was teaching at Stanford. Arrow brought me to a new startup in the Rockies. He wasn't sure where it was, but turned out to be in Santa Fe. And we had a meeting there with Phil Anderson. Arrow brought 9 other theorists besides me. Anderson brought 9 or 10 physicists and mathematicians. And we got together to think of the economy as an evolving complex system. The meeting was a great success. The Santa Fe Institute said, it was a startup, we're going to base our first and only research project on the economy as an evolving complex system. I was brought from Stanford to run this thing. Arrow was back in Stanford and Phil Anderson was in Princeton. I called them up in the first month or so and I said, what should we do? What should be the project? And quite a lot of money had been put into this, and I was able to get a team of about 20 people that first year. So they made some inquiries from Citibank and funders, and the word came back by telephone. There was no email, and this is how long ago this was. Do anything you want, providing it is at the foundations of economics and providing it is non-conventional. I can give you a bit of background. Maybe you can hear it from my accent. I grew up in part of the UK that wasn't quite conventional, Northern Ireland, and we were going through certain disagreements at the time with the authorities and so on. And I always thought I was free of all of that. Now I realize later in life that, no, that was basically baked into how I think. So we decided we would look at the economy seriously as an evolving complex system. And I'm going to describe kind of what that felt like. Complex system, by the way, is a bit like you take cars, put them on a freeway or a motorway. If the interaction is dense, there's a lot of cars, maybe with different drivers traveling at different speeds, they form a pattern. We call that pattern traffic. I would hasten to add, only cars exist. Traffic doesn't exist. And I once said that in a lecture, and somebody put it online immediately. How would you like to be driving with Arthur? He believes traffic doesn't exist, at any rate. So cars together heterogeneously on a motorway will form some pattern, and each car is reacting to the local pattern that concerns them, the local traffic. So complexity economics is looking, basically, the story is to look at what patterns form out of individual elements. If the individual elements are departments or firms or technologies, we're looking to see what patterns those form and how those patterns reform. Ad infinitum, they may settle down or they may not settle down. What that brings you to think about in nearly all cases is that there's a local ecology of actions, or maybe an ecology of beliefs or of strategies, or in a case, the way I would think of an ecology of technologies. That's again a word that David used this morning. Ecology meaning a loose collection of things or species or types of things that are interacting and changing, causing the overall pattern to change, and adapting and readapting themselves. So that's the best I can describe complexity economics. It's not let there be N technologies and P firms or something. It's more, we're going to look at the economy in this more fluid, heterogeneous way, and we're going to concern ourselves with how patterns form. Oop. So I want to throw into the mix here, into the ingredients, a finding that Robert Solow published in 1957. It's probably a paper you read 30 years ago, or maybe even 3 years ago if you're lucky. It's a strange paper. Bob Solow, that's the younger Solow. He lived to be 99, by the way. Bob Solow was asking what causes economic growth, 1957, a few offices away from a fairly young Paul Samuelson. And he said, okay, could it be growth in capital, factories and machinery? Could it be growth in the labor force? Yeah, indeed it was. But there was some mysterious thing left over that accounted for 80% of economic growth. That wasn't capital or labor. And the paper puzzles over this. It's a good thing to read because it's a nice mystery thing that Solow's trying to figure out. And correctly enough, towards the end of the paper, or maybe 2/3 the way through, Solow says economic growth is actually 80% due to this mysterious force. And likely that is what he called technical change. I would have called it technology, or now we just call it tech. But Solow, I think, correctly decided that 80% of economic growth was tech. And that led me, so you could say then the economy forms from its technologies. And if you have a sort of old economy at one moment, and it grows, say, 5%, it's slightly bigger in the old economy if labor force is increasing. But most of the new stuff is new, and it's new technology. And if you do the math, the old part of the economy that you decide is old starts to shrink proportionally, therefore it's shrinking exponentially down to nothing, and soon you'll have mostly new economy. That reminded me of a kind of a phenomenon you see in volcanology, be familiar to all of us. If you think of new technologies as sort of welling up from under the ground in a kind of magma flow, and they surface at places like Route, 128 in Boston, or Silicon Valley, or parts of Europe, or certainly China. It's as if new land or new parts of the economy are being created all the time by new technology. So we can think of the economy that way, not as just the old economy getting more and more efficient, but the container staying exactly the same. Rather, new things coming along and replacing the old things, and whatever you decide is old at one point starts to relatively shrink. The phenomenon, I think, is called volcanic addition or something like that. You get new lands like Iceland or the Hawaiian Islands being created by magma flows. Technology gets created that way. I wondered, was that sort of an exaggeration? Solow didn't use that particular metaphor, But I got convinced when I started to look at the Industrial Revolution. You can't see this very well. It's a rather nice picture. This is 1819, the year that Queen Victoria was born in England. This is part of England, and you can see it's an agricultural economy. There are technologies, there's a horse, there's a boat, there are cattle, farmhouses, and so on. So there is technology in here, maybe not what we'd call modern technology, 1819. But it got slowly added to. It wasn't that farms were updated, we had the same structure that was more efficient. It was that we had entirely new things. And over a period of 30 or 35 years, it looked like that. 1819 is pretty much 1820. By 1850 or 1855 or 1860, large parts of England looked like that. I'm not sure who this is. Could be Manchester, it could be Liverpool. I can remember growing up, let's say, 3 or 4 decades ago or more, but when I grew up in Belfast, and it looked like this. It doesn't look like that anymore because the economy has changed again. What I want to emphasize is not so much that the economy gets more efficient technologies, sort of what the textbooks that I read seem to emphasize. It's that new technologies come along, like new land. They're replacing or they're adding to the economy, and relatively speaking, old technologies start to shrink and disappear. So I would say, and this is where we hit on dynamic capabilities, I'm compressing a lot of argument here, but technology itself then, if we take this entire process of creating new stuff, it introduces a dynamic world of possibilities. Don't take this too seriously. I just sat down the other day and listed 3 types of change. This is familiar to everybody in this room, I'm sure. Exploration, let's see if I can get a pointer. In other words, by the way, I've spent the last 30 years of my career not in Stanford, but in tech companies, Xerox PARC, and now in SRI. He's invented a lot of what has come to be called AI and robotics and computation. So once you have a dynamic world of novel technologies creating things, you're in a world of exploration, a world of discovery, a world of creation. That creation is done by combination. And novel technologies come about more than anything by combining or recombining cleverly what already exists, and then we'll declare that to be a new technology. So if I put together atomic clocks or and satellites and use laser beams and things like that, I can pretty precisely, using mathematical methods, put together something that will tell me precisely where I am, say, on board a ship. And we'll call that global positioning. But then global positioning itself becomes available as a building block for navigation for further technologies. So it's not just that new technologies are being formed by combination. New technologies are being formed as combinations that become new building blocks in yet newer technologies. So it's not, if you do the math, the technology then increases in possibilities exponentially. it's a combinatorial effect. It increases more than exponentially and more, very much more. What I want to point out is that if you start to think this way, and the syllogism is the economy's a set of things that are put together from what already exists and give you new Lego blocks to add to the Lego set, if you like. And we have ever new possibilities. And we do all of this. We do it via exploration, via inductive means, via imagination, via creation, and in increasing returns. Come on. Get back to where we were. Increasing returns come into this, which is something I realized early on and wrote about in the 80s. Because if one technology is more out there, that technology is more understood, it's more prevalent. So if everybody's using QWERTY typewriters, pays you if you encounter a new typewriter to know QWERTY. And this causes things to lock in, causes early monopolies, it causes excess profits. Sometimes it causes a huge amount of upfront loss until the profits are realized. And this is something that I imagine is completely familiar to you here in this room. But what I want to point out is that all of this picture comes out naturally if you view the ingredients of the economy not as in some fixed machine, but in a machine that's always changing, transforming itself, adding new elements and new patterns and forming and reforming. And that becomes, as I say here, a veritable playground for dynamic capabilities. I thought maybe that was all there was to the story, but nope, there's more. The result of this new land being added to technology is that the technology frontier is seething with change. I like the word seething because it's an old-fashioned English word that means boiling. There's nothing equilibrium about new technology coming along. The whole thing's bubbling and boiling. And it happens at all scales of technology. You could have an overall set of technologies, call it AI, that's changing. You could have different things inside that, different sorts of AI, as you're all familiar with. You can have different sorts of electronics, right down to individual parts of circuits that are only a few microns across. So at all scales, at all times, the economy is seething with change at all scales and all times, or the technology is changing at all scales and all times. And if we define the economy as resulting or growing from its technologies, it's changing at all scales and all times. Not just at the scale of the firm, and one way to make steel is replaced by the Bessemer process, another way to make steel. That's Victorian technology. Nowadays, it's all, the economy is changing at all scales, at all times. And I mean changing. I want to emphasize that all of this is bringing in new things, new types, new species into whatever ecology there is. It all sounds complicated, and David Riley remarked that, at least alluded to the fact that you're relieved you didn't have to worry too much about all that degree of complication. But it's fun to kind of allow yourself to go there, see what happens. want to throw in another ingredient into the cake mix, and that is, in complexity economics, we don't necessarily want to have the standard neoclassical assumptions. So let's drop the assumption that all agents are the same. Once you drop the assumption that all agents are identical, then you sort of say, okay, well, they differ. How do they differ? From what I've observed in Silicon Valley, in general, you don't know. You may know who your rivals are, you may know who's doing what down the street, but exactly how they're thinking, what technology they're cooking up, what their resources are, what their methods are, what the government regulations will be, what the products are going to be, you know only the vaguest amount, and you're trying to compete in an area where you don't know. So the result is, by definition, what economists call fundamental uncertainty. You don't know. It's moreover, and I don't have to emphasize that, but I'll just mention it, it doesn't mean you can put probabilities on things realistically or in any rigorous way. I don't know if Intel's going to do this next year, and the probability might be 23%. What does that mean? I can tell you, and you have your own experience, it means very little. It means you don't know. They might or they might not. Fair enough. So we don't know what new technologies are coming next, and we don't know what the other players will do. In general, occasionally you might know, and you might know very well. That would mean standard game theory or something like that might apply. What I want to do is take a really nasty twist of the knife here and argue something rigorous. So let's say we want to be rigorous. Under fundamental uncertainty, decision problems are not well defined. If I don't know who's going to be the player, if I don't know how the game works, if I don't know how the game will be regulated, if I don't know what's at stake, etc., and let's say the don't know is partial, the decision problem you're in is not well defined. Ergo, the solution is not well defined. If a problem is not well defined, did Scarlett O'Hara go back to Rhett Butler after the book finishes? That problem is not well defined. Therefore, the solution is not well defined. Therefore, rational behavior in those circumstances is not well defined. Oops, sorry. Okay. Therefore, deductive rationality itself is not possible. Personally, I would like to hoist a flag over the business school in Berkeley to inspire the students and say, rational behavior is not well defined, because one of the things they do to you, they certainly did it to me in a mathematical subject, is to say, yes, we can reduce the whole world to deductive rationality, and don't worry, we've got enough mathematics so we can handle all of that. In general, in large parts of the economy, deductive rationality is not well defined if we want to be rigorous. Yet, so you would say if deductive rationality is not well defined and you're doing textbook economics, you just sort of say, okay, what can we do? We're stymied. If you can't proceed rationally, you can't proceed. That's not true. In general, managers do act. And this is where I think, this is where dynamic capabilities come in hugely. What do they do? You know more than I do about this, but from my point of view, looking at other versions of economics, I'd say, what do managers or players do in the economy? They try to make sense. I've got oil tankers. Some of them are in the Persian Gulf. How am I going to get them out? Well, hang on. I'll have to think about Straits of Hormuz. Hang on. I'm going to have to think about the US policy. Hang on. That means I'm going to have to, etc. So you're trying to make sense. You're trying to figure out. You are trying to see differently. Well, imagine there might be a canal across some part of wherever it is, Eritrea or wherever. You might be trying out new ideas, not necessarily in oil tankers, but in general. You're trying new organizational structures. You're trying new ways of thinking. You're trying new combinations. What do we put this together with that? You're chasing new opportunities. So from my point of view, sitting at an office in Silicon Valley, Palo Alto, every day, I'm not thinking about AI. I'm thinking about the ingredients of AI, the possibilities, the robotics. In SRI International, which cooked up a lot of these ideas even 20 years ago, but now the whole thing's taken off. In other words, these managers are using dynamic capabilities. I'm not showing you anything here that you haven't thought about already. That's not the point. The point is that if you start to see the economy as fluid, forming, and you drop all these assumptions that we know everything or can put probability distributions, you're in a world that forces you into dynamic capabilities. And you can't shrink away from that. And this is true in our own lives. Every so often say, I don't know what I'm going to do. And it might have to do with some personal decisions. It may have to do with career. It may have to do with some problem you're trying to solve. But you're in this world. It's an inductive world. It's not an impossible world, but it's in a world that operates the way you've been looking at it for quite a long time. I want to just summarize here and say that standard economics, standard neoclassical economics, I think has been extremely useful. I find it hard to say that, but it has been extremely useful. It is a world of order, and it's sort of Teutonic order. In German, you'd say, das ist gut ordentlich. It's proper. There's a properness to the order. Problems are well defined in that world. The deductive rationality is useful in that world. Equilibrium, it's not a bad assumption if there's not much change happening. And some of the very old organizations, maybe Catholic Church, are rather slow to change. But you will find over some period, maybe centuries, they're changing quite a bit. In a case like that, management is routine. I was thinking about this the other night, and I thought, what if you did the following thought experiment, and you say, I'm interested in how mathematics develops. Let me assume that all mathematicians are perfectly rational. That means they can do any logic they want. That's pretty good. That means that I can put any mathematical statement on the board, and a mathematician can instantly tell me, because they're infinitely rational, whether that is a true proposition or a false one. Maybe some of them are not decidable. Very good. What would mathematicians then have to do? This is the world of standard economic mathematics. These infinitely rational mathematicians might have to check answers, or they might have to write up papers arguing what's interesting or worthwhile. But by and large, they're not having to do that much. Actual mathematicians, and I've been there, and maybe others have, you're in a world of exploration if you're good at this stuff. You're exploring, it's like an underground cave system, and it's dark, and you have a little lantern, and you're seeing new pathways, and you think, oh my God, I've gone down this, I'm stuck here, I can't. And you might end up there until 400 years later, somebody discovers that you were there before them and didn't get out. So I would describe that world as, I'm looking at the adjectives I've used, pristine. It's rather beautiful. It's been cleaned up. It's pure. It's elegant. It's artificial. Not like artificially intelligent. It's just artificial. It doesn't exist. But maybe it's worth thinking about. But the phrase I would use for it is that it's an ice palace. I think in 1844, Hans Christian Andersen wrote a book called The Snow Queen, and she lived in a palace made of ice. And it was an incredibly beautiful place. However, if you knocked sideways or you came home drunk one night and you knocked at a pillar, it might cause the whole thing to collapse. So again, I'm not being very flattering here. It's beautiful, elegant, and fragile. The sort of economics that I've been crusading for, I called it complexity economics in a paper in Science in 1999. An editor called me from London and said, we think you've got a new type of economics here, it needs a label. I said, no, it doesn't. Yes, it does. No, it doesn't. And finally, he insisted, he says, you need to give this a new label. I'm standing with a telephone, old-fashioned one in my hands. This is, what, close to 30 years ago. I said, okay, call it complexity economics. They did, and for some reason, that particular label caught on. That's a world of organicism. I can find the right. It's organic. It uses metaphors like an ecology. Things add on to what's before. Things inhibit other things. It's a world like the biological world is of action, not a world of nouns, more of this and less of that. It's a world of things acting, a world of indeterminacy, a world of sense-making, of non-equilibrium, of path dependence, and dynamic capabilities. So I think a lot of you in this room are probably saying, yeah, but we knew all that. What I would like to emphasize is that if you go this long pathway of seeing the economy this different way, you finish up inevitably with dynamic capabilities. You don't have to assume them. They sort of fall out as being a kind of a necessary way to cope. If you don't know, you have to make sense. You have to explore. If you're in the dark underground, you may not be able to light up everything or have a map with you and have perfect knowledge. You're stumbling, you're feeling the walls. I would describe that approach as, I describe that approach, I still haven't mastered this. That approach as organic, it's algorithmic. I hate to use that word, but it means that it doesn't mean it's computational or that anybody's trying to sell you something. It means that it's one event or one set of actions causing or inhibiting another. In that sense, it's algorithmic. And it's full of messy vitality. There's an architect I admire called Robert Venturi, wrote a gorgeous book in 1965 called Contradiction and Complexity in Architecture. And he contrasts, and this is well before my time, he contrasts what he calls prim dreams of pure order. Architecture in those days was too ordered, too much Bauhaus for him. And he contrasted prim dreams of pure order with messy vitality. I think messy vitality is what is a wonderful phrase. It's Robert Venturi's, and Venturi was pointing out with the word vitality that it's alive. Dynamic capabilities are not second order or second class. They're not an avoidance of, well, we're too stupid to apply perfect deduction. They're actually pointing to living in the actual world and probing and trying to find out how things really do work. I want to finally show you, this is David Collender, sometime around 2009, maybe a bit before that, he came up with a metaphor that I call Collender's two mountains. David Collender's a history of economic thought person in the US at Middlebury. Collender said, okay, imagine this, the year's 1870, and all the economists in the world, they're thinking about new methods and new explorations in economics, and they all agree to come to this village. And what they want to do, they know, or they arrive in the village, there are two gigantic mountains in front of them, and they want to climb one of them. They only have 3 weeks and they can only climb one of them. Both mountains are shrouded in cloud and they don't know which is the more interesting or the higher mountain. So they climb the mountain, he says, of well-definedness and of order. And they get to the top of that mountain of well-definedness, perfect deduction, perfect rationality, and managers who don't know, who don't have much to do. And they arrive at the top of that mountain, they find out above the clouds that the other mountain's taller, and it looks extremely interesting. This is the mountain of ill-definedness and of organism. Basically, they've climbed the wrong mountain. I would modify that slightly to say I don't think in the 1870s mathematics or logic or science was well developed enough. They didn't have computers to keep track of things. So I don't think it is quite well enough to say we're going to look at something as complicated as what I've been describing. So they probably climbed the right mountain. But maybe it's time to back off, go back to base camp, and think about this other mountain. Thank you very much.
We've got time for a few questions. Brian, I have one for you myself, which is, we are in a room where actually industrial economics is probably push back on the neoclassical finesse more than most parts of economics. At the same time, we're here with a capabilities framework, and we're on the outs trying to push in. So I'm asking you to think about the hypothetical. If you started with a capabilities view and then migrated towards neoclassical, what might that look like versus where we are, which is we're fighting a paradigm battle because we started with some version of neoclassical. And I don't know if this is true. I heard it third hand, but my colleague at Berkeley, Joe Farrell, said when he was running, was it DOJ or whatever, if he couldn't put a case into a formal model, or he didn't know how to handle it until he could put it into a formal model, and then he had the confidence to proceed. And that gives me shivers, because I think if he could put a case into a formal model, he probably didn't get it right, because I doubt that the complexity of the case would allow that. But maybe I'm wrong, and maybe he had an algorithm that was powerful enough in neoclassical economics to do that. Now, you pointed out the capabilities is sort of algorithmic, and if I can remind you of something you've written extensively about, which is the difference between verbs and nouns in economics. And I think neoclassical economics is about nouns. We're all about verbs. And the real economy is about verbs, and particularly the technology-driven economy and dynamic competition is all about verbs. So how do we, I'm not going to ask you if you got Pia's job on Monday morning, how are you going to evaluate a merger? But can you give us sort of a top-down view of what a regulator would? Okay, then you can ask that question after I finish this. But
I'll answer it twice.
what sort of rules, if you could have rules of what sort of methodological, what mindset would you bring to the monopoly problem, mergers and acquisitions? I think questions of collusion are easily pushed out of this. We can all agree that Section 1 issues remain the same, but the whole Section 2 in the US and mergers and acquisitions, I think, look different through these two lenses. So can you give us two or three things that we should keep in mind?
Well, that was, I could say, can you rephrase that in 15 words?
No.
Hang on. It's fine.
I wish I could. AI probably could.
I think this is a rather large area, but I'll do my best just to give you a quick impression. I think any subject, and economics in particular, gets insights from the instruments, think telescope or microscope, the instruments it uses to look at the object in question. And economics for a long, long time relied on geometry as its main official, well, armchair theorizing, case studies in history, routine geometry. And then finally, in the 1870s and on, basic algebra and calculus. And as you remarked, if you use algebra, the requirement in algebra is that we're all taught in mathematical economics, linear algebra, whatever else. The requirement in all algebra is that any things you're talking about have to be nouns and quantitative nouns. So everything gets reduced in economics to quantities, to rates of something, to levels of something, levels of prices, indexes. These are all nouns, and this gives you very upsy-downsy economics when it comes to, this went up, that went up. I was listening the other night to the result of the war that the US and others have caused. And it's basically, well, oil is up, such and such is up, and rates, interest rates and such are down. So that's fine. You can get quite a long way looking at that, but it's limited what you can see. What really happened was not complexity or complexity economics. What really happened is that about 40 years ago, we all got computers. And that didn't, I don't think computers via computation have changed anything much. What they're really good at, though, is keeping track of complicated situations. So, and they're also very good at keeping track of actions. Do this 100 times, sort that, change this, inhibit that. These are all verbs. And do such and such a routine multiple times. So you can now get in economics, you've got a new instrument. It's like telescopes are invented roughly around 1610, Galileo, roughly in this town here, or pretty close to it. A few streets away, probably, I don't know. But it's very much we have a new instrument in economics. Every time you get a new instrument in economics, such as mathematics or algebra, and now the ability to keep track of complicated situations, you get resistance. And I think I totally agree with what you're saying, David, that the type of economics you're dealing with in management probably has much more to do with actions. Acquire this, cut this off, bring in this, explore that, test this, and if then situations, if that happens, then do such and such. All that works very well to match computation. So we have a new instrument, and we, meaning all of us collectively, have the ability for the first time in the last 20 to 40 years of looking at actions. And this is causing both a lot of resistance and a lot of new exploration. I want to just give a word for, there's a wonderfully smart and apparently very grumpy computer scientist called, Dutch, called Edsgar Dijkstra, Dijkstra. And he was asked, what's special about computer science? And he came back and he said, computer science is to computers what computers are to computer science as telescopes are to astronomy. So there's this whole world of astronomy out there, whole universe, fabulous collections of somewhat heterogeneous billions or trillions of stars and galaxies out there, and they weren't caused by the telescope. The telescope's an interesting way to get a handle on them. We still don't know that much about them. The computer's one possible way, and thinking in terms of actions are a possible way to think differently and think much more managerially. If management if management means anything, a lot of it's about trial and error, probing, making sense, venturing, etc., all verbs. And maybe that allows us a new vocabulary. It doesn't require computers. If we were infinitely smart or infinitely rational, if I can borrow from neoclassical economists, we wouldn't need computers. we'd be able to do all those calculations in our head.
Thank you. We've got some other questions here. Peter,
Sorry.
for sure.
Yeah. Well, how am I going to do policy approach? And I'm not resistant to the particular approach. I think very nice approach. It's fascinating. The colleagues and judges are that's important. But clearly, there's a very out of what you can model on safety system. Right? For policy, I need to know where I'm going and how things are going to change if I do take a given action as a policy. The problem is that, as you said, precisely I can't even assign probabilities. If you do 1,000 simulation, what would the metric of probability means across, what is just a subset of things that can be done.
Yeah.
Okay? So when I look at this, well, that's a fundamental. When I look at this in my own like the telescope, is that if what you're interested in is really showing the possibilities, like for example, look, COVID hits, it's going to hit in a very complex system. We've never had this before. People are very transparent. I could see that complexity of this at some level of complexity analysis be very helpful in opening my eyes to the possibilities of the danger.
That's right.
Why? Because this setup, my objective function will be special.
Yep.
Might be a bit of a limit. I want to just avoid the worst. In that case, I don't need probability, and that can be very useful. But on the other hand, if you go towards, say, measurable things, I'm not quite sure that that is kind of non-versus action, because if action is what managers do, and then person make an interaction the one which is determined by manager's decision, I kind of support that you want to get that right. But maybe for this kind of question, we need a bit more, even if artificial precision in what we do, then starting with what we have and then introducing some more complexity in manners that we can handle it. Maybe for that would be the right approach.
That's a good question. These are all good questions. I must say, I think we're very early days, actually. I'm not much of a person who's I haven't looked very much over my career at policy. But what I would say is that we have a new type of laboratory in which we can build models. And it's an art to build models, no matter what point of view you take. And we could have basic versions of some healthcare model, and we could put that on a computer and run it. And then we could say, are there regions of parameter space or, where this happens or that happens? In other words, when all's said and done, this isn't a fixed solution to anything. It's a different way of looking. And that different way of looking gives you a new set of tools. And a complexity theorist that very much impressed me, John Holland, Michigan, he used to talk about flight simulators for the mind. So it's something like that. I don't think this particular point of view will be the last word in economics, and I don't think it depends on digitization or computation totally. That's just really keeping track. But it gives you the ability to think in terms of actions far more than we could before. I wrote a paper, you might, if I may, that had the title, All Systems Will Be Gamed. This was written, I wrote it in 2010, just after the 2008. What's that? Yeah, Oh, so anyway, I basically was asking, can we set up models of some part of the economy where there might be policy, and in the future, something we call AI could probe those to see if they could game the system or if they could bring up things we hadn't thought of. So when the US, and before them, by the way, the British went into Afghanistan, maybe 100 years before that, they were surprised there were insurgencies, and in Iraq. Well, that's what wargaming's all about. Somebody can maybe just sit at the table and say, you're going to do this, you're going to do this. Well, I have a narrow channel here that all shipping's got to get in and out of. I can do that. Can you make that something that's discovered by AI? My answer is yeah, but you can't think of everything, and AI won't think of everything. So I want to emphasize, I would give a sort of medium positive go ahead here, saying it's worth looking at questions, whether they're policy ones or managerial ones or exploratory ones, allowing ourselves to use verbs. Try this, try that, do that. Yeah.
I might be missing components. And then it was sometimes I use a complexity model. Try that I also small, see if we can bring something quite different. And
Yeah.
that relates to
Maybe it won't, but maybe it occasionally
This
will.
is
That's essentially what pharmaceutical companies can do with AI. Try many different combinations almost instantaneous, or protein folding. What will this look like? What will that look like?
Brian, we're getting between the wine and the dinner. So look, thank you so much for coming, the person that pioneered so much of this work. Hopefully, with this very weighty and interesting discussion, we can continue it over dinner, and hopefully it'll lead us into a new paradise of economic analysis that we'll all be comfortable with.